Imagine building this billion-dollar state-of-the-art AI fortress.
Right.
You outfit it with the most sophisticated behavioral guardrails ever conceived, and then, you accidentally upload the master architectural blueprints and the keys to the front door to a public website
Right.
in a 60-megabyte file. And yesterday, that was not some, hypothetical thought experiment. That was Anthropic.
It is the absolute definition of an unforced error. It really exposes a fascinating blind spot in the current tech landscape.
Yeah, total lump.
We are watching these companies pioneer mathematics and neural architectures that frankly border on magic, while simultaneously tripping over deployment infrastructure that the rest of the software industry standardized like a decade ago.
Welcome to today's deep dive. If you are an enterprise IT practitioner listening to this right now, there is a very good chance you are still reeling from the events of yesterday.
Oh, I bet they are.
March 31st, 2026. It's already going down as one of the most chaotic, bizarre, and fundamentally educational 24 hours in recent software history.
Without a doubt.
We're unpacking the catastrophe surrounding Anthropic, the makers of Claude, and their flagship developer tool, Claude Code. But we really need to set the mission statement for this deep dive immediately.
Right, because there's a lot of noise out there right now.
Exactly. This is not about the hype. We are not here to debate, the philosophical implications of artificial general intelligence or alignment theory.
Leave that to Twitter.
Right. Today is strictly about verifiable facts, specific numbers, and separating that deafening noise from the actionable intelligence you actually need to protect your environments today.
Which is crucial, because yesterday, we didn't just witness one massive event.
No, we witnessed two massive, completely concurrent events. First, an unprecedented source code leak of a major AI tool.
Yeah.
And second, a highly dangerous, totally separate supply chain attack that occurred on the exact same morning, targeting the exact same developer ecosystem.
And that convergence, having those two events happen on a single morning is what makes this situation so incredibly hazardous to navigate.
It really is.
It's very easy for a security team to conflate them, right? To panic over the wrong thing. But for the professionals listening, you have to understand the risk profiles of those two events are entirely distinct.
Completely different stakes.
One is an existential crisis for Anthropic's intellectual property. The other is a direct, immediate threat to your own internal servers.
Right. So let's lay out the blueprint for this deep dive. First, we're going to forensically examine how Anthropic leaked their own source code. Again.
Emphasis on again.
Yeah, we'll get to that.
Yeah.
Second, we're going to look at the unreleased secrets hidden inside that leaked clone. And third, we'll tackle that separate malicious supply chain attack, separate the risks, and deliver the final operator verdict with concrete action items.
Sounds like a plan.
So let's start by looking at the leak itself, because the mechanics of how this happened are just almost unbelievable.
They really are.
I want to introduce you to the protagonist of this whole situation. His name is Shofan Shou. He's an intern at a blockchain security firm called Fuzzland.
Shout out to the interns, always finding the biggest bugs.
Always. So on the morning of March 31st, Shou was simply checking the NPM registry for the newest release of Claude Code, which was specifically version 2.1.88.
Right.
And within 30 seconds of downloading the package, he found a glaring anomaly. A 59.8 megabyte .map file attached directly to the release.
Yeah, and to give that some context for anyone who, doesn't spend their days managing node packages, most NPM modules are measured in kilobytes.
Right, they're tiny.
Exactly. A few megabytes is considered a heavy package, so finding a nearly 60 megabyte file hanging off a command line tool package is like seeing a commercial airliner parked in a residential driveway.
That's a great way to put it.
It immediately signals that something has gone terribly, terribly wrong in the build process.
I want to dig into the mechanical reality of what a .map file actually is, because understanding that explains why this was so devastating.
Sure.
If I'm writing modern web software or like a command line tool, I'm likely not writing raw vanilla JavaScript. I'm probably writing TypeScript.
Right, because you want type safety.
Exactly. I want interfaces. I want my code to be highly structured and readable for my human colleagues. So I'll have descriptive variables like calculate enterprise billing total. And my logic is going to be spread across hundreds of meticulously organized files.
And that human readability is essential for development, right? But computers don't need human readability.
They couldn't care less.
Right. Browsers and Node.js environments don't natively execute TypeScript. They execute JavaScript. So your beautiful TypeScript has to go through a compilation phase.
Okay, but it doesn't stop there.
No, it doesn't. because network bandwidth and parsing times are critical constraints in software delivery. So developers run that compiled code through a process called minification.
Right. And minification isn't just like deleting spaces, it's a structural transformation of the code.
Exactly. A minifier parses your code into what's called an abstract syntax tree, or an AST. It understands the underlying logic of your program, and then it aggressively rewrites it.
It just shreds it.
It strips out every comment, every line break, every space. But more importantly, it mangles the variables.
So my calculate enterprise billing total function.
The minifier realizes the computer doesn't care about that long name, so it renames it to a single letter, like A.
Wow.
And it might squash 3 different files into one massive, unbroken line of text. The end result is highly optimized, incredibly fast to download, and completely incomprehensible to a human being.
Right. So if I ship that minified gibberish to production and the application crashes for a user, the error log is going to tell me, fatal exception at variable A on line 1, column 45,000.
Which is utterly useless.
Exactly. To me, as an engineer trying to debug it, I don't know what A is anymore. And that is exactly why .map files or source maps were invented in the first place.
Precisely. A source map is a literal translation dictionary. It's structured as a JSON object, and it maps the optimized code back to your original source.
How does it do that efficiently?
It uses this fascinating mathematical encoding called base 64 variable length quantity. It maps the exact line and column of the minified gibberish back to the exact line, column, and file of your original human-readable TypeScript.
Okay.
It basically tells your debugger when the computer fails at A, show the developer line 452 of the billing module.
Which means a source map is, by definition, the master blueprint of your software.
100%.
It contains the skeleton, the variable names, the file structure, everything you explicitly tried to hide by minifying it.
Yeah.
So a .map file is strictly an internal artifact. It belongs in your secure error cracking system like Sentry or Datadog or on a local developer's machine. It has absolutely zero business being packaged up and shipped to the public NPM registry.
Shipping the source map alongside the minified code completely negates the intellectual property protection that minification provides.
It's like taping the combination to the safe.
Exactly. And this is why standard continuous integration and continuous deployment pipelines CI/CD exist. A basic pipeline should have automated linters and threshold alerts.
Like what? What would that look like?
A simple script that says, before we publish this artifact to the world, check for any files ending in .map. If you find one, fail the build.
That seems so basic.
Or even simpler. If the total package size suddenly spikes from 2 megabytes to 60 megabytes, halt the release and page an engineer.
Right. The fact that a 60 megabyte file slipped through means those automated guardrails simply weren't there, or, I don't know, they were actively bypassed.
Yeah.
But the map file alone wasn't the final nail in the coffin, was it? Because a map file usually just contains the structural references and variable names. It doesn't always contain the raw source code itself.
No, it doesn't always. But in Anthropic's case, this specific .map file pointed directly to where the original unminified source files were being stored.
Oh, boy.
And they were being hosted on Anthropic's own Cloudflare R2 storage bucket.
Which brings us to the second, compounding catastrophic failure here. Cloudflare R2 is an object storage service, functionally equivalent to Amazon S3.
Yep.
It's basically a massive cloud hard drive.
Mm-hmm.
By default, when you create an object storage bucket, the permissions are strictly private. You have to actively write an identity and access management policy, an IAM policy, to expose that bucket to the public internet.
Right. It takes effort to make it public.
So Chaifan Shou inspects the map file, sees the URLs pointing to the Cloudflare R2 bucket, and just navigates to it.
Yeah,
And what does he find?
He hits the jackpot.
The bucket isn't just misconfigured, it is wide open. The zip archive containing the entire unsquashed original code base is sitting there without a single layer of authentication required. Anyone with a web browser could download it.
It is a textbook failure of defense in depth. If the build pipeline had caught the map file, the public wouldn't have known the bucket URL.
Right.
And if the map file had leaked, but the bucket had been properly secured with strict access controls, the attacker would have the map, but no way to access the treasure.
The breach required both the CI/CD pipeline and the cloud infrastructure permissions to fail simultaneously. And they did.
They absolutely did.
Let's quantify the scale of that exposure, because this wasn't just like a minor utility script. We are talking about specific numbers here. The zip archive contained approximately 512,000 lines of TypeScript.
That's massive.
Spread across roughly 1,900 individual files. It laid bare the complete unredacted architecture of Claude Code, which is Anthropic's flagship developer tool.
Yeah, we're talking about API routing logic, prompt injection defenses, context window management.
And entirely unreleased features.
Yeah.
And because of the unforgiving speed of the internet, the genie wasn't just out of the bottle. Within hours of the intern discovering this, the entire code base was downloaded, unpacked, and mirrored across GitHub.
Thousands of stars and forks. And once source code hits GitHub and starts generating forks, it becomes mathematically impossible to scrub it from existence.
It's gone.
You can issue all the DMCA takedown notices you want, but the code already resides on thousands of local, encrypted hard drives globally. Competitors, independent security researchers, malicious threat actors, they all now possess a high-definition, perfectly preserved snapshot of how one of the leading AI labs in the world engineers its tools.
Anthropic's official response to this was predictably sanitized. I'm going to read their statement.
Please do.
A spokesperson confirmed the incident to the press, stating, "Earlier today, a Claude Code release included some internal source code. No sensitive customer data or credentials were involved or exposed. This was a release packaging issue caused by human error, not a security breach. We're rolling out measures to prevent this from happening again."
Calling it a release packaging issue caused by human error is technically accurate, I guess, but it heavily downplays the systemic nature of the problem.
I have to strongly push back on the human error defense here. Humans make errors. That is a constant. That is why we build automated CI/CD pipelines in the first place.
Right, to catch the human error before it reaches production.
Exactly. If your pipeline allows a 60 megabyte map file through, that's not just a tired engineer making a mistake at 3 a.m. That is an architectural failure of your deployment security.
I agree completely.
And the context makes it so much worse because this wasn't a one-off anomaly. This is a repeat offense.
And that is the most damning historical context of this entire incident. Just 13 months prior to this event, in February 2025, Anthropic suffered a nearly identical source map leak on an earlier version of Claude Code.
13 months ago.
Yes, they made the exact same operational mistake, shipped the map file, got burned, presumably promised to fix it, and then 13 months later, replicated the exact same pipeline failure.
And if we look even closer at the timeline, just 5 days before this massive 512,000 line leak on March 26, 2026, they experienced a separate misconfiguration in their content management system that accidentally exposed Claude Mythos.
Right.
2 significant, highly embarrassing accidental public disclosures of internal assets in a 5-day window.
When you synthesize that timeline, it paints a very clear, very concerning picture of their internal culture.
What does it tell you?
Well, Anthropic employs arguably some of the most brilliant machine learning scientists and researchers on the planet, right? They are building neural networks that can reason through complex logic, generate entire applications, parse enormous data sets. They're operating at the bleeding edge of theoretical computer science.
Absolutely.
But they're fundamentally struggling with standard IT operational discipline.
It's a striking dichotomy. Building an advanced large language model requires deep mathematics, massive GPU clustering, data science, but securely deploying that model into a production enterprise environment requires an entirely different, incredibly boring skill set.
Boring is the key word.
Right. It requires rigid change management, automated regression testing, infrastructure as code auditing, and a deeply paranoid mindset regarding cloud access policies. It is overwhelmingly clear that the AI industry right now is heavily over-indexing on the theoretical science at the severe expense of basic operational hygiene.
Exactly. And while the mechanics of the leak itself serve as a phenomenal cautionary tale for DevOps teams, what happened next was even more revealing.
Right, Act 2.
Because once the vault door was left open and all 512,000 lines of code were sitting on GitHub, security researchers didn't just point and laugh. They started reading.
Oh, they dug right in.
And what they found inside those 1,900 files completely shifted our understanding of Anthropic's roadmap and their internal development culture.
The leaked code base provided this unfiltered, completely un-PR managed look at what Anthropic is actually building behind closed doors. And there were 3 major discoveries buried in the TypeScript that we really need to unpack for you today.
Let's start with the most technically significant one.
Yes, an unannounced system called KAIROS. That is spelled K-A-I-R-O-S. The code reveals KAIROS is fully built, and it functions as an autonomous daemon mode for Claude Code.
And for the enterprise IT managers listening who might not spend their time in Unix environments, the concept of a daemon is critical to understand here.
Can you define it?
Sure. In traditional operating systems, a daemon is a background process that runs continuously, silently, without any direct active intervention from the user.
Yeah.
Your system clock, your network manager, your print spooler, those are daemons.
Right.
What KAIROS represents is Anthropic embedding that continuous background processing paradigm directly into their AI tool.
According to the source code, KAIROS is designed to activate and run while the user is idle. The code specifically mentions its purpose is to consolidate memory and merge observations.
Yeah.
So if I'm an engineer actively using Claude Code in my terminal, I am driving the interaction. I ask it to write a Python script. It writes it. It is a reactive paradigm. But KAIROS flips that entirely. If I step away from my keyboard to get coffee, the AI doesn't just sleep.
Precisely. While your machine is idle, KAIROS wakes up. It begins autonomously reviewing the files you have been editing. In the context of large language models, consolidating memory likely means it is updating its local vector database, creating new embeddings based on your recent work, and finding semantic connections between, say, a file you modified 3 hours ago and the architecture document you just opened.
So it's organizing its thoughts.
It is actively structuring its understanding of your local environment so that when you sit back down, it has a pre-computed holistic context of your project.
Which is a staggering technical achievement. But if I put on my Chief Information Security Officer hat for a second, it is an absolute nightmare.
Oh, it's a huge headache.
We have spent the last 3 years building enterprise threat models around reactive AI. We assume data only leaves our environment when an employee explicitly types a prompt and hits enter. We can monitor that interaction, we can build firewalls around it, but an autonomous agent.
Yeah, a daemon that proactively scours a developer's local file system.
Reading and processing code while the developer isn't even in the room?
It radically alters the enterprise risk profile. You have to ask yourself, how does an autonomous AI interact with data loss prevention, or DLP, agents running on the endpoint?
Right.
If KAIROS is constantly reading files to merge observations, is it going to trigger massive CPU spikes? Is it going to trip heuristics in your endpoint detection and response tools because a single background process is suddenly reading 10,000 files in the sysr trajectory?
That's a great point. And furthermore, if an engineer temporarily clones a highly restricted repository to their local machine, one that the AI isn't authorized to view, does KAIROS automatically ingest it before the engineer has a chance to restrict the permissions?
Exactly. The discovery of KAIROS proves that the era of AI as a passive conversational chatbot is over.
We're moving to active agents.
The industry is quietly moving toward AI as an active continuous background worker, and our current compliance frameworks, our DLP policies, our endpoint monitoring tools, they are entirely unprepared to handle a proactive intelligence residing on the local file system.
It is a profound shift in computing. But what makes this leak so fascinating isn't just the futuristic, paradigm-shifting AI agents. Woven right alongside KAIROS was code that perfectly encapsulates the deeply human reality of software engineering.
This is my favorite part.
Underneath the billion-dollar valuations and the very serious talk about artificial general intelligence, developers are still just people who get bored and like to build fun things.
You were talking about the buddy system.
I am. Amidst the unbelievably dense TypeScript files handling neural network routing and context window tokenization, researchers uncovered a fully fleshed out, incredibly detailed internal system called Buddy. It is, quite literally, a virtual pet system.
Like a Tamagotchi.
Yes, built directly into the enterprise AI developer tool.
The sheer volume of engineering effort dedicated to this virtual pet is remarkable. The code dictates that every single user of Claude Code is assigned a unique virtual pet. But to ensure that you get the exact same pet every time you boot up your terminal, they couldn't just use a standard random number generator.
No, that would be too easy.
They implemented a Mulberry-32 pseudorandom number generator algorithm.
Let's explain why they went to that length for you listening. Why couldn't they just use a standard, math.random function?
Because computers are fundamentally deterministic machines. They cannot generate true randomness on their own. Standard random functions often rely on the current system time, which means they output a different result every microsecond.
Right.
If they use that, your virtual pet would change species every time you ran a command. A pseudorandom number generator like Mulberry-32, however, allows you to input a specific seed value.
And in this case, that seed is the developer's unique user ID.
Exactly. The algorithm performs complex bitwise operations on that seed to produce a result that looks entirely random, but will consistently output the exact same random number every time you feed it that specific user ID.
So they utilized advanced, highly efficient mathematical bitwise operations solely to guarantee that if your user ID rolls a virtual cat on Monday, you still have a virtual cat on Friday.
That's dedication.
But it goes so much deeper than just cats and dogs. The Mulberry 32 algorithm powers a complex system of rarity tiers. Just like a modern video game's loot box system, most users will roll a standard, common pet. But a small percentage of users, dictated purely by the math of their user ID seed, will receive a rare variant.
Yeah.
The code even contains logic for shiny variants, complete with custom terminal color outputs.
It's a brilliant piece of gamification. I mean, imagine being an enterprise IP professional. You're just trying to compile your code, and you realize you accidentally rolled a shiny virtual pet.
It's so funny. But the buddy system also inadvertently revealed a hilarious yet deeply insightful detail about Anthropic's internal development friction. It involved how they managed to get a virtual duck into the system.
Ah, yes, the duck workaround.
It is my absolute favorite artifact from this entire leak. So Anthropic obviously utilizes incredibly strict content safety filters. They have heavily tuned algorithms designed to intercept and block any generated text that might be harmful, offensive, or inappropriate.
Right.
And crucially, they dog food these systems. The developers building the AI have to work within the confines of the same safety guardrails they are building for the public.
Right. If you're building a text generation tool, even if it's just generating assway art for a virtual pet, it still has to pass through the internal alignment filters to compile successfully.
So the engineers wanted one of the virtual pet species to be a duck. But for some reason, the internal safety filters were so aggressively overtuned that they constantly flagged the word duck as a violation.
Which is wild.
We can only speculate why. Perhaps the tokenizer was confusing it with a very similar-looking profanity. Or maybe the heuristic matching was simply too broad. Whatever the reason, the engineers physically could not type the word duck into their own source code without the internal safety police halting the build process.
What do they do?
Exactly. Did they file a JIRA ticket with the alignment team to adjust the model weights? Did they go through a 2-week compliance review to whitelist the word?
Of course they didn't. They are software engineers. Their primary objective is to make the code compile. If there is an obstacle, they will engineer a path around it.
Exactly. To bypass their own company's safety filters, the developers encoded the word duck into hexadecimal format.
That is just incredible. To clarify for the non-developers listening, hexadecimal is essentially a different numerical alphabet used by computers.
Right.
Instead of our standard base 10 system, which uses digits 0 through 9, hexadecimal is a base 16 system. It uses 0 through 9, and then the letters A through F to represent data.
Okay.
Every letter in the English alphabet can be translated into a 2-character hex code. So to a human, or a rigidly programmed string-matching safety filter, a hex string looks like absolute meaningless gibberish.
Just random numbers and letters.
But when the software actually runs, the compiler seamlessly translates that hex gibberish back into the word duck.
They intentionally obfuscated their own code, writing it in machine-readable base 16, specifically to sneak a virtual pet past the multi-million-dollar AI alignment filters they themselves built.
It's amazing.
It is the Jurassic Park rule of software engineering. Developers will always find a way. If you place a guardrail in front of an engineer, and that guardrail introduces friction or seems illogical, they will not stop coding. They will just build a ramp over it.
It is a highly amusing anecdote, but it also highlights a very real, very expensive problem within the AI industry. The sheer amount of friction these internal alignment tools create is immense.
Yeah, think about the time wasted.
If your top-tier engineers are wasting time writing obfuscated hex code just to render a virtual duck, because the safety models are too brittle, you have to ask how much engineering velocity is being sacrificed across the entire organization to appease these internal systems.
Which provides the perfect transition to the absolute centerpiece of this deep dive. Because if we are talking about wasted engineering effort, internal systems, and the obsession with AI safety, we have to examine Undercover mode.
Oh, Undercover mode.
Of all the 512,000 lines of code leaked, Undercover mode represents the most profound, staggering irony of the entire March 31st incident.
Undercover mode is arguably the most complex, resource-intensive, and highly engineered subsystem found within the Claude Code architecture.
So, what exactly was Anthropic so afraid of that they felt compelled to build Undercover mode in the first place?
They were terrified of their own creation.
Wow.
When an enterprise user is interacting with Claude Code, the AI is constantly generating text, suggesting functions and analyzing context.
Right.
But large language models are notoriously unpredictable. They hallucinate, and they can sometimes regurgitate data from their training sets.
Right.
Anthropic's deepest fear was that during a casual interaction with a customer, the neural network might accidentally blurt out internal Anthropic IP.
Like spilling the company secrets?
They were worried the AI would leak future product roadmaps, mention top-secret code names like KAIROS, or expose internal infrastructure routing details.
They needed to prevent the AI from acting like a corporate whistleblower.
Precisely. So they dedicated an immense amount of engineering resources to construct Undercover mode. It is not just a simple keyword blocker. It is a highly sophisticated, real-time output interception layer.
How does it work?
Before any text generated by the AI is rendered on the user's screen, Undercover mode intercepts it. It scans the output against a dynamically updated, massive database of internal intellectual property, code names, and sensitive network architecture.
Okay.
If it detects a potential leak, it sanitizes the output, redacting or modifying the text in real time before the user ever sees it.
I really need you, the listener, to pause and absorb the magnitude of this. Anthropic spent millions of dollars in venture capital dedicating thousands of hours of elite engineering talent to build a state-of-the-art real-time policing system.
A massive undertaking.
They built an impenetrable titanium vault door from the inside out, specifically to ensure their AI model would never, ever leak a single syllable of internal intellectual property to the public.
That was the entire design philosophy of the system.
And yet, the grand irony, they meticulously secured the AI, but they shipped their entire 512,000 lines source code, including the uncompiled code for Undercover mode itself in a .map file, pushed it through a completely standard, unaudited NPM build pipeline, and left it sitting publicly on a misconfigured Cloudflare storage bucket.
It's hard to even wrap your head around.
An intern looking at an NPM registry found the master blueprints in 30 seconds. It forces a massive question about the current state of the tech industry. Are we suffering from a collective terminal case of myopia?
I think we might be.
We are so hyper-fixated on the grand science fiction threats of AI alignment and rogue superintelligence that we have completely forgotten the fundamental realities of IT security 101.
The evidence strongly suggests that, yes, the threat models at these leading AI labs are deeply, dangerously skewed. If you read the white papers and the manifestos coming out of these organizations, there's an overarching obsession with existential risk. They are running simulations to ensure the AI doesn't learn to actively deceive its creators or develop autonomous capabilities to manipulate financial markets. And to be fair, long-term AI safety is a valid research vector.
Of course.
But yesterday proved that while they are standing at the front door with a shotgun, scanning the horizon for a Terminator, they have left the proverbial back door wide open, unlatched, swinging in the wind, vulnerable to the most mundane, boring, basic operational IT failures imaginable.
You don't need a rogue, super-intelligent neural network to orchestrate a devastating corporate data breach if a junior DevOps engineer can accidentally push the entire proprietary codebase to a public web server because a CI/CD artifact size check was disabled.
Exactly.
The delta between their brilliant visionary AI safety posture and their complete lack of basic deployment discipline is a vulnerability that threatens the stability of the entire software ecosystem.
Because eventually that lack of discipline stops being an intellectual property problem for Anthropic and starts becoming an infrastructure problem for their customers.
Which is exactly why we need to pivot sharply to Act 3 of this deep dive. Everything we have discussed so far, the .map file, KAIROS, the hexadecimal virtual ducks, the staggering irony of Undercover mode, all of that is ultimately an informational disaster for Anthropic.
Yes, very embarrassing for them.
It compromises their competitive advantage. But if you are the enterprise IT practitioner listening to this right now, Anthropic losing its source code does not directly compromise your local server.
No, it doesn't.
However, while the entire tech media was fixated on laughing at Anthropic's cloud bucket mistake, a completely separate, highly malicious, and deeply sophisticated attack was launched targeting the exact same developer ecosystem. And this attack absolutely does compromise your servers.
This is the moment we had to separate the noise, the news cycle, from the signal of actual operational danger.
Let's do that.
The Claude Code leak dominated the headlines because it involved a famous unicorn startup and unreleased AI secrets. It has narrative flair. But the concurrent supply chain attack that occurred on the NPM registry just hours earlier is the actual literal fire that enterprise security teams need to extinguish today.
Let's lay out the precise parameters of this synchronous nightmare. On the morning of March 31st, while the AI world was distracted, attackers compromised a package on the NPM registry called Axios. Before we get into the attack vectors, we need to establish the stakes. Just how foundational is the Axios package to modern software?
Calling it foundational is almost an understatement. Axios is a promise-based HTTP client for JavaScript and Node.js.
Yeah.
Historically, making network requests in JavaScript meant dealing with the incredibly clunky XML and HTTP request API, or dealing with the idiosyncrasies of the native fetch API across different browsers. Axios abstracted all of that away into a clean, intuitive, highly reliable interface.
So everyone uses it.
As a result, it became the absolute de facto standard for network communication. If you are building a web application, a mobile app in React Native, or a back-end Node server, and you need that software to talk to an external API or fetch data from the internet, you are almost certainly using Axios.
Wow.
It is downloaded tens of millions of times every single week.
So targeting Axios isn't like targeting a single building. It's like poisoning the concrete used to pave the entire interstate highway system. Every modern application relies on it. What was the exact window of compromise?
The malicious actors managed to push compromised versions of the Axios package live to the NPM registry between 0.21 and 0.3.25 UTC on March 31st, 2026.
That is a roughly 3-hour window.
Right. If your automated CI/CD systems or your local developers ran an NPM install during that specific window, they were at extreme risk. The specific affected versions that contained the malicious payload were Axios version 1.14.1 and Axios version 0.30.4.
How does a supply chain attack of this magnitude actually function mechanically? Like, if I am a developer and my code says npm install Axios, I am relying on automated trust. My computer reaches out to the central official npm registry, asks for the package, and downloads it. How does an attacker weaponize that trust to compromise my local machine?
The vulnerability lies in a deeply flawed historical feature of the NPM ecosystem called post-install scripts.
Ah, post-install scripts.
To understand why they exist, you have to look back at the early days of Node. Developers frequently needed to use JavaScript to interact with lower-level system libraries written in C or C++ sounds. Packages like Node SAS or database drivers needed to be physically compiled on the host machine to work with that specific operating system.
Okay, that makes sense.
So NPM introduced post-install scripts. It is a feature that allows a downloaded package to execute arbitrary shell commands on your computer the exact millisecond it finishes downloading automatically.
It was intended to run a compiler, but it essentially grants a third-party package the immediate right to execute code on your machine without asking for further permission.
Exactly. It is a massive, gaping security loophole that the JavaScript ecosystem has struggled with for a decade. Now, how the attackers gained the credentials to publish a malicious version of Axios is still under investigation.
Right. Could be anything.
It could have been credential stuffing against a maintainer's account, a hijacked session token that bypassed two-factor authentication, or sophisticated social engineering.
Yeah.
But once they had publish rights, they were incredibly clever about how they hid the payload.
They didn't just write malicious code directly inside the Axios files, did they?
No, because that would be too obvious. Any security researcher diffing the code against the previous version would spot a massive block of obfuscated malware immediately. Instead, they weaponized the dependency tree. Modern software is built on deeply nested dependencies. You install package A, which relies on package B, which relies on package C. The attackers modify the compromised versions of Axios to declare a brand new, seemingly innocuous dependency.
And what was that?
A completely obscure, newly published package called Plain Crypto.js version 4.2.1.
I see the logic. My CI/CD server needs to build my application. The lock file or the package.json says I need Axios. The server pulls down the compromised Axios 1.14.1. Axios then tells my package manager, before I can function, I require you to also download plain crypto.js.
Yep.
Because package managers automatically resolve dependencies, my server blindly reaches out and downloads that package as well.
Precisely. The core Axios code looked relatively clean. The malware was entirely sequestered inside plain crypto.js, and it was inside that obscure crypto package that the malicious post-install script was waiting. The moment plain crypto.js version 4.2.1 finished downloading, the post-install script triggered, silently executing shell commands in the background of the developer's machine or the CI/CD server.
What was the actual payload delivered by that script? Once it executed, what did it do to the host machine?
The script initiated an outbound network connection to a command and control server and downloaded a remote access Trojan, commonly referred to as a ORA.
For the enterprise managers who usually deal with policy rather than malware analysis, let's clearly define what a remote access Trojan does in this specific context.
The ORAT is exactly what the name implies. It is malware designed to open a permanent, stealthy backdoor into your operating system. Once installed, it establishes a reverse shell, giving the attacker on the other end of the internet the exact same level of administrative control over that machine as the developer sitting in front of the keyboard.
They can do anything.
They can log keystrokes, view the screen, navigate the file system. But in the context of a developer machine or a CI/CD server, they aren't looking to steal your family photos. They are looking for one specific target: environment variables.
They want the .env files.
Yes. Developer environments and build servers are littered with highly privileged credentials: AWS access keys, production database passwords, Stripe API tokens, cloud infrastructure deployment keys. The RAT is specifically programmed to scrape these environment variables, read local AWS credential files, and quietly exfiltrate them back to the attacker server.
This is exactly why we have to draw a hard, definitive line separating the risks of these two events. The Anthropic Claude Code .map leak is like a world-famous, highly exclusive restaurant accidentally dropping its closely guarded secret recipe book in the middle of a busy public street.
Yes.
It is devastating for the restaurant. Their competitors are going to pick it up, analyze their techniques, and start copying their signature dishes. It erodes their market advantage. But for the consumer who eats at that restaurant, it is perfectly safe. The food hasn't changed, the chairs haven't broken. It is purely an informational, intellectual property crisis for Anthropic.
That is the perfect analogy. Anthropic's bleeding is corporate, not operational for the end user.
But the Axios supply chain attack, that is fundamentally different. That is like someone breaking into the municipal water treatment plant and poisoning the town's water supply. It is a direct, immediate, and catastrophic threat to the health of the consumer.
Yes, it is.
It is a severe operational crisis for any organization whose systems drank the water mean and downloaded the NPM packages during that specific 3-hour window.
The distinction is vital because enterprise IT and security teams operate with strictly limited time, bandwidth, and resources. If a CSO spends today panicking about the Claude Code source leak demanding audits of how their developers are using Claude, they are wasting valuable cycles worrying about Anthropic's IP problem.
Exactly.
If they prioritize that over investigating the Axios attack, they're actively leaving a highly privileged backdoor open in their own infrastructure. You must ruthlessly prioritize the operational risk to your own network.
Which brings us directly to the operator verdict. We have explored the mechanics of the leak. We have unpacked the supply chain attack. We have separated the informational noise from the operational signal. Now we need to deliver the final concrete assessment for the enterprise IT practitioners tuning in. What do they actually need to do the moment this deep dive ends? Walk us through the exact action items.
The strategy breaks down into 3 distinct steps: watch, act now, and adopt.
Okay, let's start with step 1.
Step 1 is WATCH. If I'm an IT director, my instinct might be to rip Claude Code out of my developer's hands because of the leak. But functionally, the tool is not broken. The API still works. But you must understand the macro environment has shifted.
Because the blueprint is out there.
Exactly. Because every major competitor and potentially malicious threat actors now possess a detailed architectural blueprint of Anthropic's tool, including the internal routing logic of KAIROS and the specific constraints of Undercover mode. We are likely going to see an acceleration of targeted attacks against Anthropic's backend infrastructure. You don't need to ban the tool today, but you need to actively monitor Anthropic's stability and security posture over the next quarter.
Okay, step 1 is watch. Acknowledge the landscape has changed, but hold the line. What is step 2? Because this is the critical emergency response phase.
Step 2 is ACT and now W. This requires immediate, decisive forensic action across your entire engineering organization. You must determine with absolute certainty if any of your systems pulled packages from the NPM registry on March 31 between 0.21 and 03.25 UTC.
How does a security team practically execute that across a company with hundreds of microservices and dozens of developer laptops? What are they specifically looking for?
You do not rely on developers remembering if they ran an update.
No, they won't remember.
You rely on the cryptographic truth of the log files. You need to instruct your DevOps teams to immediately grep and audit every single log file in your organization. That means package -lock.json for standard NPM, yarn.lock if you use Yarn, or pnpm-lock.yaml.
Okay.
A log file is an exact deterministic ledger of every single dependency version installed in a project. You must search those files specifically for Axios version 1.14.1 or version 42.4.
Yeah.
Furthermore, you must search the dependency trees for the malicious payload mask, plain crypto.js version 4.2.1.
Let's play out the worst-case scenario. A security engineer runs that grep command across the CI/CD server cluster, and it returns a positive hit. They find plain crypto.js 4.2.1 in the log file of their primary billing service. What is the immediate protocol?
If you find that package in a log file, you must immediately assume a full system breach. There is no time for nuanced forensic analysis of whether the post-install script successfully executed. You must treat that specific developer laptop or that specific CI/CD build container as utterly compromised by a remote access Trojan.
Wow. Okay, so what's the first move?
Step 1. Physically isolate the machine from the network. Step 2, and this is the most critical, you must instantly, without hesitation, rotate every single API key, database credential, AWS IAM token, and environment variable that the compromised environment ever had access to.
Rotating enterprise credentials is an absolute nightmare. It breaks builds, it causes downtime, and it requires coordinating across multiple teams.
It is incredibly painful, but it is the only way to ensure the blast radius is contained. The RAT was explicitly designed to exfiltrate those credentials. If those specific versions of Axios and plain crypto.js were installed on your machine, you have to assume your AWS root keys belong to the attackers now.
They're gone.
If you do not rotate them, the attackers will use them to pivot from a compromised developer laptop directly into your production cloud infrastructure.
Okay, step 1 is watch Anthropic. Step 2 is act now on Axios. Grep the log files and rotate keys if compromised. What is step 3?
Step 3 is ADDO-PT. And this is a fascinating architectural recommendation coming directly from Anthropic in the immediate aftermath of this chaos. Going forward, Anthropic is explicitly advising enterprise users to stop using NPM to install Claude Code.
Wait, let me make sure I understand that. The multi-billion-dollar AI company that built the developer tool is publicly telling developers not to use the world's most popular package manager to install it.
Yes, because the events of March 31st vividly demonstrated that the NPM ecosystem, while undeniably convenient for rapid development, is structurally fundamentally vulnerable to these exact types of deep tree supply chain attacks.
Too many dependencies.
The web of nested dependencies is simply too vast to audit, and the permission model of post-install scripts is inherently dangerous. Anthropic is strongly urging security-conscious enterprise teams to adopt their native installer instead.
A native installer being a standalone, pre-compiled binary executable that you download directly from Anthropic's own servers, completely bypassing the NPM registry entirely.
Exactly. Utilizing a native binary fundamentally alters your supply chain risk profile. You are no longer implicitly trusting a sprawling, decentralized network of open-source maintainers who might have their credentials stolen. You aren't vulnerable to a nested package pulling in a IAID via a post-install script. You are establishing a direct, one-to-one chain of trust with the vendor.
That makes total sense.
So the directive is clear. Adopt the native installer and systematically deprecate the NPM installation method for Claude Code across your entire organization.
That is a highly definitive, actionable roadmap for the IT practitioners listening today. Watch, act now, adopt. We have covered a truly massive amount of ground in this deep dive.
We really have.
We traced the mechanical failure of a CI/CD pipeline, allowing a 60-megabyte map file into the wild. We explored the surreal discoveries within those 512,000 lines of code, from the profound implications of the KAIROS background daemon to the developer culture revealed by Hex-Encoded virtual ducks. We examined the staggering irony of Anthropic building Undercover mode to protect secrets, only to leak them via basic human error.
Incredible irony.
And most importantly, we dissected the mechanics of the Axios supply chain attack and how a nested dependency delivering remote access Trojan threatens your infrastructure right now.
It truly was a watershed 24 hours.
Mm-hmm.
March 31st forced the entire industry to confront the brilliant innovations, the bizarre cultural quirks, and the fundamentally deeply broken aspects of modern software delivery, all at exactly the same time.
And as we wrap up this analysis, I want to leave you, the listener, with one final, perhaps unsettling thought to mull over as you run those grep commands on your log files today. We spent a lot of time discussing the enterprise risks of AI demons and supply chain malware. But consider the broader implications of step 3.
Yeah.
If a giant, heavily funded organization like Anthropic is now publicly advising developers to abandon NPM, bypass the open registry, and rely exclusively on their closed native proprietary installers to ensure security, are we washing the beginning of the end for the open source package ecosystem?
That's the big question.
As supply chain attacks become increasingly devastating and automated, is the free, interconnected internet of shared code about to fracture? Are we moving toward a future where software development becomes a series of isolated corporate walled gardens simply because the open fields are too dangerous to walk through? It's a profound shift in how we build technology, and the Axios attack might just be the catalyst that accelerates it.
That is the larger, slower-moving crisis beneath all of this. We might be securing the endpoints today, but we are fundamentally altering the collaborative nature of software development in the process.
You can find everything at aifrankly.com. Subscribe free on Substack, watch on YouTube, and listen on Apple Podcasts and Spotify. Just search AI Frankly.
AI, frankly. Are we having fun yet?